Hello there, and welcome to the calm space of LUMIVERSE NL, a calm window to the cosmos. Maybe you've had a long day, or maybe you're the kind of soul who finds peace in the rhythm of distant stars. Tonight, we begin a gentle voyage into the silent ocean of space, a place where science breathes slowly, and every fact glows like a lantern in the dark. Take a deep breath. Let your shoulders rest. Let your thoughts wander. You don't need to understand everything that follows. Just listen. Because the universe itself has a way of teaching through stillness. In this quiet moment, we'll drift through stories older than memory, of galaxies expanding faster than light, of stars large enough to cradle worlds within their glow, and of invisible forces that hold everything together, including you. The cosmos isn't rushing anywhere. It turns softly, endlessly, at its own tranquil pace. For centuries, humans have looked upward and called it space. But what lies beyond is not empty. It is alive. Every flicker of starlight you see tonight began as energy from an ancient sun. That light traveled for millions, sometimes billions of years, just to reach the small mirror of your eyes. You are literally seeing history unfold. Each photon, a message written at the dawn of time. Imagine that vastness, a universe stretching across billions of galaxies, each one filled with hundreds of billions of stars. Within that infinite field, our Milky Way spins quietly, a single spiral of light among countless others. And on one tiny planet orbiting an ordinary star, you are here, breathing, listening, existing. It's easy to forget that connection. Yet the atoms in your body were once forged inside ancient suns. The calcium in your bones, the iron in your blood, the carbon in your breath. All of it was born in stars that died long before Earth even existed. To know the universe is to know yourself. You are made of the same light that fills the sky. So as this journey begins, don't try to stay awake for every moment. Let the knowledge flow through you like soft waves of sound. Some facts may surprise you. Others may calm you. All of them are true, and all of them are beautiful. Close your eyes if you wish. Feel the slow rotation of the earth beneath you, the quiet pull of gravity anchoring you to the stars. The night is patient, and so is the universe. Tonight, space becomes a lullaby, and science a form of peace. The universe is not still. It is growing, stretching, expanding into silence. If you could watch it unfold from above time itself, you would see galaxies drifting apart like petals carried by a cosmic wind. Each moment, space becomes larger. Not because the stars are moving through it, but because space itself is growing. This expansion began nearly 14 billion years ago, with a spark of unimaginable density and light, the Big Bang. It was not an explosion in space, but the birth of space and time themselves. From that instant, the universe has been breathing outward, filling the void with galaxies, radiation, and the seeds of life. Even now, that breath continues. Einstein once said that nothing can move faster than light. And yet, the early universe broke that rule. Not by moving faster, but by stretching faster. The fabric of reality itself expanded at a speed beyond imagination, carrying galaxies away from each other before light could ever catch up. That moment of cosmic inflation shaped everything that exists today. The rhythm of time, the distance between stars, the very silence between your breaths. Look around you, even here on Earth. The night sky you see is not fixed. The light from distant galaxies is stretched thin, turning red as space expands. This faint red glow is called cosmological redshift, a soft reminder that the universe is still unfolding. Every ray of starlight is a message written on a moving canvas. Some galaxies are now so far away that their light will never reach us. They are beyond the horizon of our visible universe, islands of stars sailing away forever. we will never see them. But they remain part of the same cosmic story, bound to us by origin, if not by sight. It's a humbling truth. The cosmos is larger than we can ever know, yet it began smaller than a single atom. Imagine for a moment the sound of that expansion. Not noise, but a slow vibration of space itself. Astronomers have measured the faint afterglow of the Big Bang, a whisper of light called the cosmic microwave background. It fills the universe like a quiet memory, an echo of creation that hums softly through every corner of existence. You are surrounded by that glow even now. It passes through your body, through the air, through everything. The universe never stops speaking. We simply learn to listen. So when you gaze up at the stars tonight, you're looking back in time. Every point of light is a message delayed by distance. Some are only a few years old. Others began their journey billions of years ago when galaxies were still young. To look outward is to look backward, to see not what is, but what once was. The night sky is a living archive of time, and within that slow expansion, there is peace. The same force that carries galaxies apart also carries your breath in and out. The same rhythm that shaped the stars beats quietly in your chest. You are not separate from the cosmos. You are one of its ways of knowing itself. So take another slow breath. Let the vastness remind you how smallness can still hold infinity. Let your thoughts drift with the galaxies, moving outward, softly, endlessly, because in the calm expansion of space, there is something deeply human, a quiet wish to keep growing, even in silence. Among the endless stars, there are giants so vast they could swallow entire worlds without noticing. They are called red supergiants, ancient furnaces of fusion, burning with the last of their strength before collapsing into death and rebirth. If one of these stars replaced our sun, its outer layers would stretch beyond the orbit of Jupiter. The Earth, Mercury, Venus, and Mars would all drift inside its glowing skin, suspended in fire. These titans, like UY Scuti or VY Canis Majoris, are not solid, but made of clouds, great, luminous veils of hydrogen and helium, pulsing in slow rhythm. Their edges shimmer like fog backlit by eternity, and their gravity, though immense, feels strangely gentle at the surface. Standing near one, if such a thing were possible, you would see nothing but light, horizon to horizon. A living sun so large it would make your heart tremble with its quiet power. But their lives are fleeting. While our sun will shine for 10 billion years, a red supergiant burns itself out in only a few million. It consumes its core in a race against gravity, until one day, the gravity wins. The star collapses inward, rebounds outward, and in a heartbeat explodes as a supernova. For a few weeks, that single dying star can shine brighter than an entire galaxy. In that moment of destruction, the universe creates. The intense pressure of the explosion forges elements heavier than iron, gold, silver, oxygen, and carbon. The very materials that would one day form oceans, mountains, and living hearts. Each breath you take contains the ashes of a star that once burned across the galaxy. Every cell in your body carries a memory of that ancient fire. It's strange to think that our world, calm, green, alive, was born from cosmic violence. But that is how the universe works. Beauty from collapse, light from pressure, life from death. Without those explosions, there would be no solid ground beneath your feet, no air to breathe, no sun to rise. We are the children of stellar endings, walking beneath skies still echoing with their light. Astronomers have even watched this process unfold. They've seen supernova remnants, glowing clouds of dust and gas, expanding through space like a slow-motion blossom. Within those clouds, new stars begin to form, gathering the scattered elements of their ancestors. And around those newborn suns, disks of dust swirl and merge into planets. Somewhere in one of those systems, a world like ours might already be taking shape. When Carl Sagan said, "We are made of star stuff," he wasn't speaking in metaphor. It was literal truth, one of the calmest and most beautiful facts in all of science. Your bones, your thoughts, your heartbeat, all trace their origin to the death of a sun. So when you look up at the night sky and see a bright star burning alone in the dark, remember that it might also be looking back, knowing that one day its light will become life somewhere else. And that is the quiet promise of the universe. Nothing is ever truly lost, only transformed. Because even when the stars die, their light goes on, scattered across space, waiting to become part of someone's breath, part of someone's dream, part of you. Far beyond the warmth of our sun, in the frozen twilight of the outer planets, there are worlds that shimmer with impossible storms. Here, the sky is not blue, but deep sapphire, and within it, scientists believe it rains solid diamonds. On planets like Neptune and Uranus, the atmosphere is thick with methane gas. Under immense pressure and temperature deep below their clouds, carbon atoms are squeezed together until they crystallize, falling like glittering hail through layers of gas that stretch for tens of thousands of kilometers. Each storm releases flashes of light as carbon transforms into diamonds, then sinks slowly toward the planet's molten core, where it melts again into liquid carbon. This strange cycle, rain that turns into gems, is not fantasy, but physics. In laboratories on Earth, researchers have recreated these conditions using high-powered lasers. They compress methane until it bursts into diamond dust, proving that what happens billions of kilometers away can be mirrored right here, in the heart of human curiosity. Imagine looking up into that alien sky. The clouds churn like thick blue velvet, illuminated by lightning you can't hear. And through the silence, diamonds fall, tumbling through an endless atmosphere, flashing once, then vanishing into the dark below. There are no oceans there, no sunlight, no air to breathe. Yet in the stillness, the planet glows softly from within, as if the universe itself decided to decorate the cold with beauty. Neptune's winds are the fastest in the solar system, reaching over 2,000 kilometers per hour. They rip across the planet's surface in great invisible ribbons, shaping storms that have lasted for decades, maybe centuries. Unlike Earth, these tempests never rest. They are the breath of a world made of ice and gas, moving to rhythms we can only imagine. And still, somewhere beneath those clouds, diamonds fall. Each one begins as a whisper of carbon, a speck of starlight trapped in gas. Gravity pulls it downward, and for a brief moment, it exists. A solid jewel suspended in an ocean of sky. It never reaches the surface because there is no surface to reach. Instead, it melts away into the liquid depths, becoming part of the planet's endless cycle of transformation. Scientists even suspect that entire diamond oceans could exist deep inside these worlds. Imagine that. Vast seas of molten carbon, glimmering in darkness, with diamond icebergs floating in silence. No light, no sound, only pressure and time. A place so distant, so harsh, and yet so exquisite that it feels almost like art. It reminds us that nature doesn't need to be seen to be magnificent. Beauty exists even where no eye can witness it. Planets, stars, and storms all follow the same quiet principle: that creation and destruction are two halves of the same rhythm. From the fire of supernovas to the frost of Neptune, the universe expresses itself not in words, but in transformation. When we dream about space, we often imagine chaos, explosions, collisions, cosmic violence. But in truth, much of the universe is slow. It drifts. It changes gently, endlessly, almost patiently. Planets like Neptune are not places of fury, but of still creation, where pressure becomes sculpture and time becomes light. Perhaps that's why these facts calm us, because in every chaotic heartbeat of human life, there exists a reflection of this cosmic stillness, a reminder that beauty doesn't always announce itself. Sometimes it simply falls, quietly, like rain made of diamonds in a blue and silent sky. Far beyond the warmth of our sun, in the frozen twilight of the outer planets, there are worlds that shimmer with impossible storms. Here the sky is not blue, but deep sapphire, and within it, scientists believe it rains solid diamonds. On planets like Neptune and Uranus, the atmosphere is thick with methane gas. Under immense pressure and temperature deep below their clouds, carbon atoms are squeezed together until they crystallize, falling like glittering hail through layers of gas that stretch for tens of thousands of kilometers. Each storm releases flashes of light as carbon transforms into diamonds, then sinks slowly toward the planet's molten core, where it melts again into liquid carbon. This strange cycle, rain that turns into gems, is not fantasy, but physics. In laboratories on Earth, researchers have recreated these conditions using high-powered lasers. They compress methane until it bursts into diamond dust, proving that what happens billions of kilometers away can be mirrored right here, in the heart of human curiosity. Imagine looking up into that alien sky. The clouds churn like thick blue velvet, illuminated by lightning you can't hear. And through the silence, diamonds fall, tumbling through an endless atmosphere, flashing once, then vanishing into the dark below. There are no oceans there, no sunlight, no air to breathe. Yet in the stillness, the planet glows softly from within, as if the universe itself decided to decorate the cold with beauty. Neptune's winds are the fastest in the solar system, reaching over 2,000 kilometers per hour. They rip across the planet's surface in great invisible ribbons, shaping storms that have lasted for decades, maybe centuries. Unlike Earth, these tempests never rest. They are the breath of a world made of ice and gas, moving to rhythms we can only imagine. And still, somewhere beneath those clouds, diamonds fall. Each one begins as a whisper of carbon, a speck of starlight trapped in gas. Gravity pulls it downward, and for a brief moment, it exists. A solid jewel suspended in an ocean of sky. It never reaches the surface, because there is no surface to reach. Instead, it melts away into the liquid depths, becoming part of the planet's endless cycle of transformation. Scientists even suspect that entire diamond oceans could exist deep inside these worlds. Imagine that, vast seas of molten carbon glimmering in darkness, with diamond icebergs floating in silence. No light, no sound, only pressure and time. A place so distant, so harsh, and yet so exquisite that it feels almost like art. It reminds us that nature doesn't need to be seen to be magnificent. Beauty exists even where no eye can witness it. Planets, stars, and storms all follow the same quiet principle. That creation and destruction are two halves of the same rhythm. From the fire of supernovas to the frost of Neptune, the universe expresses itself not in words, but in transformation. When we dream about space, we often imagine chaos, explosions, collisions, cosmic violence. But in truth, much of the universe is slow. It drifts. It changes gently, endlessly, almost patiently. Planets like Neptune are not places of fury, but of still creation, where pressure becomes sculpture and time becomes light. Perhaps that's why these facts calm us. Because in every chaotic heartbeat of human life, there exists a reflection of this cosmic stillness, a reminder that beauty doesn't always announce itself. Sometimes it simply falls, quietly, like rain made of diamonds in a blue and silent sky. In the aftermath of stellar death, something extraordinary can remain, a remnant so dense, so compact, that it bends the very fabric of reality. These are the neutron stars, the silent hearts of once mighty suns, spinning alone in the darkness like cosmic lighthouses. When a massive star explodes in a supernova, its outer layers are blown away, but its core collapses under its own gravity. Protons and electrons fuse into neutrons, and matter is compressed to a density beyond imagination. A single teaspoon of this substance would weigh billions of tons on Earth. If you could somehow hold it in your hand, the gravity would crush you before you could even blink. Yet out there, in the vastness of space, these stars endure. Tiny, only about 20 kilometers wide, but carrying more mass than our sun. They rotate hundreds of times per second. Their magnetic fields trillions of times stronger than Earth's. Each spin sends beams of radiation sweeping through space, and if one of those beams crosses our line of sight, we see a rhythmic pulse, a flicker as precise as a clock. That's why we call them pulsars, beacons of perfect timing scattered across the galaxy. Some pulse so steadily that they keep better time than the atomic clocks we build on Earth. Astronomers use them as cosmic metronomes, mapping the galaxy, testing gravity, even measuring the ripples of space-time itself. Imagine standing near one. The airless silence, the crushing pull, the blinding beams of radiation. The surface glows with trapped energy, a crust of atomic nuclei over an ocean of superfluid neutrons. Here, the rules of normal matter break down. Atoms cannot exist. Light bends into strange arcs. Time itself slows. If you were to drop an object toward a neutron star, it would accelerate to half the speed of light before impact. The resulting collision would release more energy than an atomic bomb. Yet these stars do not explode again. They remain balanced between gravity's hunger and the pressure of quantum mechanics, a harmony so delicate it could last for billions of years. Occasionally, they do something even stranger. They quake. A sudden shift in their crust, like a starquake, can release bursts of gamma rays that outshine entire galaxies for a few seconds. These are the cosmic equivalents of lightning, brief, furious flashes in an otherwise silent universe. Some neutron stars are even more extreme. Magnetars with magnetic fields strong enough to distort atoms and twist space itself. If one were as close as the moon, its magnetic power could erase every hard drive on Earth. It's an impossible force, invisible, silent, yet absolute. These objects remind us how thin the line is between creation and collapse. They are what remains when a star dies, yet they still spin, still shine, still mark time. A pulsar is the echo of a heartbeat that refuses to fade. It pulses through the void, saying, "I am still here." We often speak of black holes as the ultimate mystery, but neutron stars might be more haunting. They are not gone, not consumed, but preserved in tension, a perfect balance between life and oblivion. They are the memory of a star compressed into eternity. So when you hear about one of these spinning ghosts, imagine its pulse echoing across light years, passing through clouds of dust, crossing empty space, arriving faintly at our telescopes. A single beat, repeated endlessly, a reminder that even in death, the universe keeps time. Somewhere in that rhythm, perhaps, is the same quiet pulse that runs through you. The same pattern of motion, the same will to continue. Because in a universe built on collapse and rebirth, even the silence has a heartbeat. Not every galaxy shines. Some are nearly invisible, vast, ghostly collections of gas and dark matter drifting through the cosmos without light. They are called dark galaxies, and they are among the most mysterious structures ever discovered. For centuries, we believed that galaxies were made of stars, great islands of light scattered across the universe. But as our telescopes grew sharper, astronomers noticed something strange. The way galaxies moved didn't match the light they gave off. Stars on the outer edges were orbiting far too fast, as if some unseen gravity was pulling them from within. This invisible influence came to be known as dark matter, a substance that doesn't emit or absorb light, but outweighs all visible matter in the universe 5-1. We cannot see it, touch it, or capture it, yet its gravity holds galaxies together, shaping the cosmic web like invisible threads woven through infinity. Dark matter makes up the scaffolding of the universe. Galaxies form along its filaments, clusters gather in its knots, and empty voids stretch between its vast, unseen strands. Where dark matter flows, light eventually follows. It is the unseen architect of everything we know. But some galaxies never quite lit their lamps. These dark galaxies contain massive amounts of gas, the raw material for stars. And yet, for reasons still unknown, they never ignited into starlight. They drift in the cosmic dark, detectable only when their gravity bends the light of something behind them, or when radio telescopes pick up faint whispers of hydrogen gas swirling in their depths. They are fossils of creation, frozen blueprints of how galaxies might have formed, but never did. Studying them is like looking back in time, to an era before the universe was fully awake, before light carved the first patterns into the cosmic fog. Imagine floating through one of these hidden realms. No stars, no glow, only a faint mist of gas stretching across billions of kilometers. Your ship's lights would vanish into emptiness. The silence would be complete, the kind that presses against your thoughts, the kind that makes you realize how fragile light truly is. And yet, within that darkness, there is structure. Gravity still sculpts the gas into shapes, spirals, filaments, halos. Dark matter still flows like invisible rivers, guiding the unseen motion of everything around it. Even in total obscurity, the universe remains beautifully organized. It's a paradox that feels almost poetic, that the most abundant form of matter is the one we cannot see, that everything we know, every planet, every person, every atom, exists because of something we can only infer from its shadow. Dark galaxies remind us that visibility is not proof of existence. The unseen can still be powerful. The invisible can still define reality. In fact, most of reality might be invisible. Astronomers continue to search for these dim giants. They use gravitational lensing, the bending of light by mass, to trace where dark matter lies hidden. When the light of a distant quasar bends into arcs or rings, it reveals a ghost galaxy lurking in between, a silent guardian shaping the path of light without ever shining itself. Sometimes the discovery is almost emotional. To realize that the universe is built on the unseen, that everything luminous floats upon an invisible ocean, is to feel both humbled and expanded. You could say dark matter is the universe's way of keeping secrets. Or perhaps it's a reminder that light alone does not tell the full story. There is beauty in what we cannot perceive. There is order in the unseen. And there is comfort in knowing that even when you can't see the pattern, you are still part of it. So the next time you look into a dark sky and think of emptiness, remember, it isn't empty at all. It's full of invisible motion, of quiet matter holding galaxies in its grasp, of forces older than time itself. In the silence between the stars, the universe is whispering softly, reminding us that even in darkness, everything is connected. Not every planet has a home. Scattered across the galaxy are worlds that drift in endless night, planets untethered to any star, wandering alone through the dark. Astronomers call them rogue planets, and their existence rewrites our understanding of what a world can be. Most planets are born within solar systems, circling young stars surrounded by swirling disks of dust and gas. But sometimes, gravitational chaos strikes. A passing star, a planetary collision, or even the tug of a giant world like Jupiter can fling a planet out of its birthplace, casting it adrift through interstellar space. Once free, it keeps moving forever. No sunrise, no sunset, no orbit to return to. Just an eternal journey through the quiet between the stars. There may be billions of these wanderers in the Milky Way, perhaps more rogue planets than stars themselves. Some are massive gas giants, others small, rocky, and cold, like frozen versions of Earth. Without a sun to warm them, their surfaces would sink to unimaginable cold, hundreds of degrees below zero. Their skies black and endless. And yet, not all of them are dead. Some scientists believe that under their icy crusts, these planets could still harbor warmth from their formation, or from radioactive decay deep in their cores. If thick enough layers of ice insulate that heat, liquid water could remain trapped beneath. Dark oceans untouched by starlight, perhaps even capable of sustaining microbial life. Imagine such a place, a planet drifting alone for millions of years, its entire world cloaked in eternal twilight. Above, the stars never rise or set. They stay fixed in an unchanging sky. Below, an ocean glows faintly from geothermal vents, its heat the only memory of a forgotten sun. No day, no year. Only the rhythm of pressure and tide, a slow heartbeat in the dark. If life exists there, it would never see the light of a star. Its entire evolution would unfold in secrecy. Creatures born of heat and mineral, learning to thrive without the concept of dawn. To them, the universe would seem endless and black, a place without direction, without sky. And yet, in their own quiet way, they would still be part of it. Tiny sparks of persistence drifting through the void. Astronomers sometimes catch glimpses of these lonely worlds through a phenomenon called microlensing. When a rogue planet passes in front of a distant star, its gravity bends the starlight, magnifying it for a few fleeting moments. In that brief shimmer, we detect the presence of a world that would otherwise remain invisible. It's a rare, silent signal, a reminder that even in the darkest corners of the galaxy, there are wanderers still moving, unseen. It's hard not to see ourselves in them. For all our technology and light, we too are travelers in a vast night, our planet orbiting one small star on the edge of a spiral arm. Earth is tethered, yes, but the difference between us and a rogue planet is only gravity. Emotionally, perhaps we understand them perfectly. The feeling of drifting, the quiet of being alone, the longing for warmth in a cold and endless sky. And yet, there's beauty in their solitude. They prove that even without light, a world can endure, can keep its oceans, its core, its rhythm. That life, or the possibility of it, does not depend entirely on stars. It depends on balance, on persistence, on the will to hold heat in a freezing universe. Maybe that's what the rogue planets are here to teach us. That isolation doesn't mean emptiness. That even in exile there is motion. That even in silence there is meaning. So when you look into the night and feel small beneath the stars, remember, you're sharing that sky with a billion unseen worlds. Planets without suns, wandering forever. Their hearts still warm, their paths still steady. They drift not toward despair, but toward endurance. And in their lonely flight, they carry the same quiet truth that echoes through every corner of the cosmos, that to exist, even in darkness, is a kind of light. At the center of our solar system burns a familiar star, the sun. We wake beneath its warmth, we live by its light, but few realize how strange, how violent, and how alive our sun truly is. It is not a still sphere of fire, but a roaring ocean of plasma, its surface seething with storms of magnetic energy, its light born from a ceaseless war between gravity and fusion. Deep within its heart, hydrogen atoms collide at unimaginable speed, fusing into helium and releasing vast quantities of energy. That energy struggles upward for thousands, even millions of years, bouncing between particles until it finally reaches the surface as sunlight. Every ray that touches your skin began its journey long before the first humans ever walked the earth. What you feel on your face today is ancient light, a message from the past, still finding its way to you across time. But here is one of the sun's strangest secrets. Its atmosphere is hotter than its surface. The visible layer, the photosphere, burns at about 5,500 mSq. Yet the outer atmosphere, called the corona, reaches temperatures of over 1,000,000 degrees. It seems impossible. How can something farther from the source of heat be so much hotter? Scientists are still trying to solve this paradox. They believe that the sun's magnetic field, a tangled web of invisible power, snaps and reconnects in violent bursts, releasing jets of energy that heat the corona from below. Each of these magnetic events can hurl charged particles into space, forming what we call solar flares and coronal mass ejections. When these storms reach Earth, they can disrupt satellites, interfere with power grids, and fill our skies with auroras, rippling curtains of green and violet light that dance across the poles. The northern and southern lights are not merely beautiful. They are the visible heartbeat of the sun's energy passing through our world. Every shimmering wave you see above the Arctic is a whisper from the sun itself. The sun's influence extends far beyond the planets. Its solar wind, a stream of charged particles, flows outward for billions of kilometers, creating a vast bubble around our solar system known as the heliosphere. It shields us from much of the cosmic radiation that drifts through interstellar space. Without it, life on Earth might never have survived. And yet, like all stars, the sun will not burn forever. In about 5 billion years, it will exhaust the hydrogen in its core. As fusion slows, gravity will cause the center to collapse, forcing the outer layers to expand and cool. The sun will swell into a red giant, its edges stretching outward until they engulf Mercury and Venus, and perhaps even Earth. From far away, it will appear as a giant ember, a swollen star glowing softly in its final act. But that ending is not tragedy. It is transition. The sun's death will scatter new elements into space: carbon, nitrogen, and oxygen, the same building blocks that once gave rise to us. Future worlds will form from its ashes. New life will emerge under new suns. The cycle will begin again. If you could stand at the edge of space and watch the sun in real time, you would see its surface boiling, shifting, each granule the size of continents. You would see flares looping thousands of kilometers high, plasma arcs glowing against the darkness. And through that motion, you would realize, this is not a star of destruction, but of persistence. For billions of years, it has burned without pause, balancing chaos with harmony, destruction with creation. It is the reason every breath exists, every shadow, every color, every living thing. And though we sometimes take it for granted, the sun is a quiet miracle, a cosmic engine that gives more than it takes, that shines not to consume, but to sustain. So the next time you step outside and feel warmth on your skin, pause for a moment. You are touching the memory of a nuclear furnace 93 million miles away. You are feeling the heartbeat of a star that has carried life through deep time. And somewhere within that endless glow lies a truth as simple as it is profound. The sun does not ask to be thanked. It simply burns, steadily, patiently, illuminating the path for everything that dreams beneath its light. Far beyond the calm blue of Earth's skies, there is a world of storms so immense that they could swallow entire planets whole. This is Jupiter, the largest planet in our solar system, a gas giant with no solid surface, a realm where thunder, lightning, and wind wage, eternal war within clouds of ammonia and hydrogen. From space, Jupiter looks serene, streaked with cream, gold, and rust, its swirling bands flowing like brush strokes of an ancient painting. But beneath those clouds lies a depth we can scarcely imagine. Each colored band is a jet stream moving at hundreds of kilometers per hour, their boundaries colliding, twisting and folding into violent tempests. The most famous of all is the Great Red Spot, a storm so vast it could engulf 3 Earths and still have room to breathe. For at least 4 centuries, this storm has raged without end. When Galileo first looked through his telescope in the 1600s, it was already there, spinning endlessly, a colossal cyclone trapped between Jupiter's jet streams. Its winds roar at nearly 500 kilometers per hour, and its crimson hue, scientists believe, comes from sunlight reacting with complex chemicals in the upper atmosphere. What gives the storm its color may also be what slowly erodes it. Over the last few decades, the Great Red Spot has been shrinking. Still enormous, but fading like an ember cooling in the wind. Jupiter's storms never sleep because there is nothing to stop them. On Earth, hurricanes eventually die when they cross land or lose their source of heat. But Jupiter has no continents, no oceans, no resting place. Its atmosphere extends tens of thousands of kilometers deep, fueled by internal heat from the planet's core. That heat, leftover energy from Jupiter's formation, still seeps outward after billions of years, powering the most dramatic weather in the solar system. Lightning on Jupiter is 1,000 times more powerful than anything on Earth. In the planet's dark bands, lightning flashes illuminate entire hemispheres, revealing towering clouds that reach heights greater than Mount Everest. Each strike releases the energy of a small nuclear explosion. If you could float within those clouds, you would never hear thunder. The air is too thin for sound to carry. But you would see the light rip through the gloom like silent fire. Jupiter is not alone in its chaos. Around it orbits a family of more than 80 moons, each one shaped in part by the planet's gravity. One of them, Io, is the most volcanically active body in the solar system, its surface constantly reshaped by eruptions that hurl lava hundreds of kilometers into space. Another, Europa, hides a global ocean beneath its icy crust, a possible cradle for life. These moons dance in resonance with Jupiter's magnetic field, which stretches millions of kilometers into space, strong enough to trap charged particles and create deadly radiation belts. To human eyes, this would be a place of beauty and danger intertwined. And yet, within the chaos, there is balance. Every band, every storm, every bolt of lightning serves a purpose. Moving heat, redistributing energy, maintaining the planet's vast equilibrium. What appears violent is, in truth, harmonious. Even the Great Red Spot, for all its rage, is part of a larger rhythm. The breathing of a planet that has never known stillness. If you could stand on one of Jupiter's moons and look back at the giant, you would see a sight unlike anything on Earth. An enormous marble of color filling half the sky. Its clouds drifting and twisting in hypnotic motion, lightning flashing deep within its layers like veins of fire under skin. It would feel alive, not just a planet, but a colossal organism made of air and motion. Perhaps that's what draws us to worlds like this. They remind us that even in chaos, there can be beauty, that storms can be eternal and still be graceful, that destruction and creation are merely different expressions of the same force. On Jupiter, there is no calm, no peace, no quiet horizon, and yet, somehow, it remains mesmerizing. Its storms are poetry in motion, and its endless winds sing a hymn that only the universe can hear. When you watch Jupiter through a telescope, you're not just observing weather. You're witnessing movement on a planetary scale, a dance that began billions of years ago and may continue for billions more. And maybe, deep down, that rhythm feels familiar. Because like Jupiter, we too are full of storms, shifting, changing, burning, yet always moving toward balance in the end. In the soft halo of Saturn, time moves differently. Here the planet glows pale gold against the dark. A silent monarch crowned with rings that stretch hundreds of thousands of kilometers wide, yet are no thicker than a few stories of a building. They look eternal, but they are not. Even the most beautiful structures in the cosmos fade. And Saturn's rings, too, are slowly disappearing. For centuries, those icy bands have inspired wonder. Through Galileo's telescope, they first appeared as ears on the planet's sides. Later, astronomers realized they were a vast system of countless particles, pieces of ice, rock, and dust, all orbiting in delicate balance. Each ring is made of billions of fragments, some as small as grains of sand, others as large as mountains, each one glinting as it catches sunlight, spinning in perfect rhythm around the planet. But Saturn's rings are not solid. They are temporary sculptures of motion, born, evolving, and dissolving across cosmic time. Every particle is caught between gravity and decay. Tiny impacts from micrometeoroids chip away at them, while Saturn's own gravity pulls their dust downward in a process called ring rain. Over millions of years, this gentle downpour of ice and dust falls through the atmosphere like snow returning home. The Cassini spacecraft, humanity's quiet traveler through Saturn's realm, revealed just how fragile these rings are. Its instruments detected streams of material falling from the rings into Saturn, a slow, invisible cascade that could erase them within 100 million years. In the measure of cosmic time, that's the blink of an eye. The rings we admire today are young, perhaps only 100 million years old, a recent shimmer added to an ancient planet. Scientists believe they may have formed from tragedy, a shattered moon torn apart by Saturn's gravity. Perhaps it drifted too close, its icy surface cracking and scattering into orbit. Or maybe a comet struck long ago, and its debris spread outward, forming the radiant bands that now encircle the world. What we see as beauty may, in truth, be the frozen echo of destruction. And yet, that is what makes them sacred, their impermanence. To know that something so magnificent exists only for a while makes it even more precious. When you look at Saturn's rings, you are seeing a cosmic moment, a fragile alignment of motion and light, a masterpiece that will one day dissolve back into shadow. If you could hover above them, you would not see solid bands but vast fields of glittering ice. Each particle would move silently beside others, orbiting with mathematical precision, forming waves and ripples like those on a calm sea. Occasionally, a small moon would glide through, its gravity carving gaps and patterns in the rings. Like a painter dragging a brush through gold dust, Cassini's final mission ended as it plunged into Saturn's atmosphere, burning up in the very planet it had studied. It was a deliberate act, a poetic ending, to prevent contamination of moons that might harbor life. As it descended, it sent back one last look, rings glowing in sunlight, planet beneath like liquid amber, and beyond it all, the faint blue dot of Earth. Our world reflected in Saturn's final gaze. Those last images are a reminder of perspective. That beauty, even when it fades, leaves behind memory. That endings in the scale of the universe are simply transformations. And that decay is not loss, it is renewal. The ice of the rings will become vapor, the vapor will become rain, and the rain will fall into Saturn, continuing the same cycle that has always shaped the cosmos. When you gaze at Saturn through a telescope, you are looking at something temporary, and that is precisely why it feels eternal. Because for the brief moment that the rings exist, they are perfect. Perfect in form, perfect in light, and perfect in the quiet truth they reveal, that even the greatest beauty is made of motion. So if you ever feel the passing of time press against you, remember Saturn's rings. Fragile, fleeting, magnificent. A reminder that impermanence can still be infinite in its grace. If the universe could remember its birth, that memory would shine not as light, but as a whisper, a faint glow stretched thin by time and distance, echoing across every direction of the sky. It is the oldest light we can see, the cosmic microwave background, the afterglow of creation itself. Long before galaxies, before stars, even before atoms as we know them, The universe was a dense, seething ocean of particles and energy. It was only 380,000 years old, a newborn still glowing with the heat of its own formation. Photons bounced endlessly off electrons, trapped in a fog of plasma so thick that light could not travel freely. But then, something miraculous happened. The universe cooled. Protons and electrons joined to form hydrogen atoms, and for the first time, light was set free. That light, once blazing and white-hot, began its journey outward. Over billions of years as space expanded, its wavelengths stretched into the gentle microwaves we can detect today. What we see now is not the fire of the Big Bang, but its fading warmth, stretched by the breath of time. In 1965, two radio engineers, Arno Penzias and Robert Wilson, accidentally discovered this cosmic whisper. They were testing a new antenna when they found a strange, persistent noise, a hiss that came from no specific direction, that couldn't be silenced or explained. They cleaned the equipment, chased every possible interference, even removed nesting pigeons from the receiver. Yet the noise remained. It was not a mistake. It was the voice of the universe itself, the remnant radiation of the Big Bang filling all of space. That faint signal changed everything. It proved that the universe had a beginning, a moment of expansion from which all matter and energy emerged. Since then, satellites like COBE, WMAPI, and Planck have mapped this ancient glow in astonishing detail. Tiny fluctuations, variations of temperature smaller than 1 part in 100,000, show the seeds of every galaxy, star, and planet that would one day form. Each bright and dark patch on that map is a frozen echo of quantum ripples that existed when time itself was new. If you could translate those ripples into sound, you would hear something like a deep, cosmic hum, a low vibration that once filled all of space. The pitch would be far below human hearing, a note that resonates not through air, but through existence itself. Every galaxy, every molecule, every heartbeat was sculpted by that ancient rhythm. The entire sky, no matter where you look, still glows faintly with that radiation. It passes through you now as you listen. Billions of photons, survivors of creation, streaming silently through your body. You are literally bathed in the light of the beginning. It is everywhere, and yet almost nothing. A few microwatts of energy per square meter. A soft background hum to all of existence. And though that glow is faint, it carries meaning. It tells us that the universe is not static, but living, expanding, cooling, changing. It tells us that time has direction, that everything we see has grown from a single, incandescent origin. It tells us that chaos can give rise to harmony, that from random fluctuations, structure can bloom. In the smallest noise, there is order. In the faintest light, there is history. When astronomers look at the cosmic microwave background, they are not just studying the past. They are gazing into the very beginning of time. Each photon they detect has traveled for over 13 billion years, carrying with it the story of the universe's first breath. To see that light is to touch the boundary between existence and nothingness. And yet, even this light is fading. As the universe expands faster and faster, the background radiation cools. Its energy stretched thinner each passing moment. Someday, it will slip beyond the range of detection, leaving behind only darkness and memory. But for now, it remains. The softest reminder that everything began with light, and that even after 13.8 billion years, the universe still remembers. If you close your eyes tonight, the darkness around you isn't empty. It's full of ancient light, stretched thin by time, still whispering the same message it has carried since the dawn, that from silence came brightness, and from that brightness, everything we know. You are not separate from that story. You are its continuation, a consciousness made from the same light that first broke free from the cosmic fog and learned to shine. Our closest companion in the sky, the moon, feels so eternal, so constant in its quiet orbit, that it's hard to imagine it changing at all. But the truth is, it is drifting away from us. Slowly, silently, every single year. Right now, the moon moves about 3.8 centimeters farther from Earth each year. It doesn't sound like much, but over millions of years, this steady retreat reshapes the rhythm of our planet. Our tides, our rotation, even the length of our days. It is a dance, and one partner is very slowly stepping back. The reason lies in gravity, a subtle tug-of-war between the Earth and the moon. As the moon pulls on our oceans, it creates tidal bulges, enormous swells of water that move around the planet. But because the Earth spins faster than the moon orbits, those bulges are pulled slightly ahead of the moon's position. Their gravity, in turn, tugs the moon forward, giving it a tiny push that increases its orbit size. The cost of this exchange is time itself. Each time the moon drifts a little farther away, Earth's rotation slows, imperceptibly but constantly. Billions of years ago, when the moon was much closer, a day on Earth lasted only about 18 hours. The tides were higher, the nights shorter, and the world spun more quickly beneath a closer, brighter moon. Over ages, as the moon moved outward, our planet's spin slowed, and days grew longer. Someday, perhaps billions of years from now, the Earth's rotation and the moon's orbit may finally lock in perfect harmony, each showing the same face to the other, forever bound in tidal stillness. We know this slow waltz is real because the moon remembers it. When Apollo astronauts placed reflectors on its surface, they left behind a way to measure the distance between Earth and moon with breathtaking precision. By bouncing lasers off those mirrors, scientists can track the moon's retreat centimeter by centimeter, watching in real time as the universe's clockwork continues. Even our planet's rocks hold the record of this cosmic choreography. Ancient coral fossils, for instance, show growth rings that correspond to daily and yearly cycles. From them, scientists can infer that hundreds of millions of years ago, a year contained more days than it does now, because each day was shorter. The moon's influence is written not only in the tides, but in the history of life itself. And what of the future? If the moon continues to move away, its hold over our tides will weaken. Eclipses will become rarer, less perfect, because the moon will appear smaller in our sky. There will come a time when total solar eclipses will cease to exist, when the moon can no longer completely cover the sun's disk. Future skies will still hold beauty, but the miracle alignment we experience today will be gone. It is strange to think that our view of the heavens is temporary, that even the patterns we call eternal are passing moments in cosmic time. The same forces that raised the tides and illuminated the first nights of Earth's oceans are still at work now, reshaping the future inch by inch. And yet, this slow drift doesn't feel like loss. It feels like evolution, a gentle separation born of gravity's compassion. The moon isn't leaving us out of indifference. It's simply following the physics of its own path, carrying forward the energy we gave it in our shared beginning. Someday, long after humanity is gone, the moon will hang smaller in the sky, its face unchanged, its pull fainter, its light still tracing silver across whatever oceans remain. But perhaps the distance will make it even more beautiful, because beauty, like the moon, is not diminished by distance. It is deepened by memory. So when you look up tonight and see the familiar glow above the clouds, know that you are watching a journey unfold, one that began over 4 billion years ago and will continue for billions more. The moon, drifting quietly away, will never truly leave us. It will always circle our world, not as a possession, but as a reminder of connection, that gravity, like love, does not disappear when distance grows. It simply stretches to hold on. There are places in the universe where gravity becomes so strong that not even light can escape. A single step too close, and everything you are, every atom, every particle, is drawn inward, stretched, and erased from existence as we know it. These are the black holes, the silent hearts of galaxies, the ultimate sculptors of time and space. For most of human history, black holes were only an idea, a strange prediction of Einstein's equations, a shadow in the mathematics of relativity. They were never meant to exist in the physical world. And yet, the universe had other plans. In 1971, astronomers found the first real evidence, a faint, flickering X-ray source called Cygnus X1, a star being devoured by something invisible. From that moment, theory became reality. Black holes form when massive stars run out of fuel. Without fusion to hold them up, their cores collapse under their own weight. If the star is heavy enough, more than about 3 times the mass of our sun, its gravity crushes everything into an infinitely dense point, a singularity surrounded by a boundary called the event horizon. Cross that horizon, and you are lost. Nothing, not even light, can return. But not all black holes are created equal. Some, called stellar mass black holes, are the remnants of individual stars. Others, the supermassive black holes, lie at the centers of galaxies, weighing millions or even billions of suns. How they formed is still a mystery. Perhaps they were born with the universe, growing slowly as galaxies gathered around them. Or perhaps they began as smaller black holes that merged and fed until they ruled the stars. And then there are those that spin, rotating at incredible speeds, dragging space-time itself around with them. In these extreme regions, nothing can remain still. Every particle, every photon is forced to move in the direction of the spin, caught in a gravitational whirlpool where time slows to a crawl. If you could orbit close enough, you would see light bend around you in full circles, stars duplicated and smeared across the sky. To an outside observer, your clock would tick slower, your heartbeat stretched into eternity. The fastest known black holes spin at nearly the speed of light. Their energy is so intense that they can hurl out jets of plasma millions of light years long. Streams of charged particles shot from their poles with unimaginable power. Paradoxically, black holes, the darkest things in the universe, can also be its brightest beacons. When gas and dust spiral inward toward the event horizon, they heat up, glow, and emit radiation strong enough to outshine entire galaxies. These are the quasars, cosmic lighthouses visible across billions of years. In 2019, for the first time, humanity saw one. The Event Horizon Telescope captured an image of the black hole in the galaxy M87, a golden ring of light encircling a void of darkness. That image was not just a photograph. It was a mirror held up to the universe itself, a glimpse of something that should not be visible, a place where physics teeters on the edge of the unknown. To approach a black hole would be to approach forever. As you neared the event horizon, you would see the universe speed up, stars racing through their lifespans in seconds, the cosmos aging and fading before your eyes. And yet, to you, time would feel normal. You could cross the horizon without noticing, and never know the exact moment you were gone. Scientists believe that information, the quantum fingerprint of reality, can never truly vanish. If so, then perhaps what falls into a black hole isn't lost, but transformed, encoded on the horizon's surface, in ways we don't yet understand. Hawking called it the information paradox, a puzzle that connects gravity, time, and the quantum world into a mystery still unsolved. But beyond the equations, there's something deeply poetic about black holes. They are reminders that the universe has boundaries not just of space, but of comprehension. They show us that even the laws of nature bend, that time itself can stretch and fold, And that light, the most constant thing we know, can still be caught. If you could look into one, you wouldn't see destruction. You'd see transformation. Matter turned into energy, energy into gravity, and gravity into the curve of time itself. Black holes are not the end of everything. They are doorways to understanding how everything begins. So when you see that famous image, the glowing ring around darkness, remember that you are not looking at a monster, but at balance, creation and annihilation in perfect silence. The cosmos folding itself inward to remind us that even in the absence of light, the universe is still profoundly alive. On a cold, rust-colored world not far from home stands the largest volcano in the solar system. It towers nearly 22 kilometers high, almost 3 times the height of Mount Everest. Its base stretches more than 600 kilometers across, wide enough to cover the entire state of Arizona. Its name is Olympus Mons, and it rises from the surface of Mars like a frozen mountain of fire. At first glance, it seems impossible. How could a volcano grow so enormous without collapsing under its own weight? The answer lies in Mars itself. The planet's gravity is only a third of Earth's, and its crust, thick, still, and ancient, never shifts with tectonic plates the way ours does. On Earth, volcanoes are temporary. They form, erupt, and move as the crust drifts. But on Mars, a volcano can sit above the same hot spot for millions of years, pouring lava over the same place again and again, building itself higher with every eruption. Over time, Olympus Mons became a mountain so vast that its slopes are almost flat, only a few degrees from base to summit. You could stand at its edge and never see the top, its curvature lost to the horizon like the curve of a planet within a planet. If you tried to climb it, you might never notice you were ascending at all, until the thin air and endless red dust gave you away. From orbit, Olympus Mons looks like a great shield of stone, its rim crowned by steep cliffs called scarps, the edges of collapsed lava flows that once spread like oceans of fire. At its summit lies a massive caldera, a cluster of craters formed by the mountain's own weight pressing down on its magma chambers. Even now, the volcano may not be dead, only dormant, its heart still warm, its silence only a pause in geologic time. The story of Olympus Mons is also the story of Mars. Once, the planet was alive with volcanic heat. Rivers of molten rock carved valleys and plains. Thin clouds gathered, rains may have fallen, and perhaps for a time, Mars breathed. But as its interior cooled, its magnetic field faded, and the solar wind stripped away its atmosphere. The oceans vanished, the skies thinned, and the volcanoes, once fierce and luminous, fell quiet. What remains is a desert world of echoes, its landscapes frozen mid-sentence, as if the planet simply stopped speaking. But silence is not emptiness. The red planet still holds secrets beneath its dust. Traces of ancient water, minerals that could only have formed in liquid, and perhaps, deep underground, warmth that never died. If life ever existed on Mars, it might still linger there, hidden in the shadow of Olympus Mons, in caves carved by lava, or in briny pockets of ice. When rovers like Curiosity and Perseverance roam the Martian plains, they travel through the debris of cataclysms that shaped entire worlds. Every rock they study carries the signature of fire, iron-rich dust oxidized by ages of thin air and sunlight. Mars glows red because it rusts, its surface weathered by time and emptiness alike. But beneath that red stillness lies the same energy that built Olympus Mons, a pulse, waiting, patient as the cosmos itself. Standing on its rim would be an experience beyond comprehension. The horizon would stretch hundreds of kilometers in every direction, the sun a pale disk in a salmon sky, its light filtered through dust so fine it never truly fades. At night, Earth would rise like a bright blue star, a reminder that home is not far but also not reachable without a miracle of machines. Olympus Mons is more than a mountain. It is a monument to endurance. It represents what happens when time, gravity, and isolation conspire to create permanence. It's a relic of an age when Mars was younger and wilder, and yet it endures in the same quiet rhythm that shapes all things in the universe, slowly, deliberately, without need for witness. Perhaps one day, humanity will stand there, looking out across the ancient plains, listening to the wind that has blown for billions of years. They will leave footprints in the dust, the first living creatures to climb the tallest mountain in the solar system. And when they do, they may feel what every explorer before them has felt, the smallness of being human against the backdrop of forever. For now, Olympus Mons remains untouched, a silent colossus under a thin, alien sky, its slopes whispering the memory of fire, its summit watching the universe in quiet, endless patience. A sleeping heart beneath the red dust of Mars, waiting for the day when light and footsteps return. In the quiet darkness between galaxies, light bends. It doesn't travel straight, as we once imagined. It curves, it stretches, it follows the shape of space itself. This strange phenomenon, predicted by Einstein over a century ago, is called gravitational lensing, and it reveals that the universe is not made of emptiness, but of invisible structure, a cosmic web woven from matter, energy, and gravity. According to Einstein's theory of general relativity, mass warps space-time. A planet, a star, a galaxy, each one bends the very fabric around it. And light, though it has no weight, must still follow that curve. So when a distant galaxy's light passes near a massive object, like another galaxy or a cluster of them, the path of that light twists, forming arcs, rings, or even multiple images of the same source. We call these shapes Einstein rings, graceful halos of distorted light scattered across the deep sky. It's as if gravity itself were a lens, a magnifying glass made not of glass, but of space-time. Through it, we can see things that would otherwise remain invisible. Galaxies too faint, too distant, too ancient to detect directly. Gravitational lensing allows us to look back billions of years, to witness the universe as it was when the first stars were born. But this bending of light also tells us something even deeper, that most of the mass causing it is not visible. When astronomers calculate how much light is bent, they find that the visible stars and gas account for only a fraction of the total pull. The rest must come from something unseen. The mysterious dark matter that makes up nearly 85% of all matter in the universe. It's everywhere, in every galaxy, shaping every orbit and every cluster, and yet it emits no light of its own. We know it exists only by the way it bends what we can see. In a sense, dark matter is the sculptor of the cosmos. It is the frame that galaxies hang upon, the hidden architecture of creation. Without it, galaxies would fly apart under their own spin. With it, they cohere. Vast islands of stars bound by invisible gravity. Every spiral arm, every glowing nebula, every cluster of suns owes its structure to something that cannot be seen. Astronomers use gravitational lensing to map this hidden matter, turning distortions of starlight into a kind of cosmic fingerprint. By studying how light from distant galaxies bends, they can reconstruct where dark matter lies, painting invisible maps of gravity across the sky. The results are hauntingly beautiful. Ghostly webs of mass connecting clusters of galaxies, vast filaments stretching for hundreds of millions of light years, and empty voids, regions of nothingness framed by everything. This great structure, the cosmic web, is the skeleton of the universe. Every galaxy we can see is merely a pearl strung along its threads, and somewhere, woven between them, are the same forces that govern our own existence. If you could travel through this vast framework, You would see galaxies gathered like glowing embers along invisible highways of matter. You would feel gravity not as a downward pull, but as a flowing current, a slow river guiding everything that drifts within it. Light would twist around unseen masses, and time itself would warp in gentle ripples as you moved. You would realize that what we call space is not empty. It is alive with shape and tension, a field in which all things move together. Even black holes, the densest objects in existence, follow this grand design. Their gravity bends the light of distant stars, sometimes creating perfect rings of mirrored galaxies around them. To look at these images is to see space behaving like water, rippling, reflecting, distorting, but never breaking. It is proof that the universe is not a static stage, but a living fabric in motion. When you gaze up at the stars tonight, the light that reaches your eyes has not traveled straight. It has curved around unseen masses, passed through the valleys and hills of space-time, and carried with it the silent history of that journey. Every photon has been touched by gravity, bent, delayed, sculpted, before it arrived to tell its story in a single spark of starlight. It's humbling to know that even light, the fastest thing we know, is not entirely free. It follows the same rules as everything else, drawn into the great geometry of existence. And perhaps that's what makes it beautiful, because in its bending we see connection, a reminder that even across billions of years and unthinkable distances, the universe still finds ways to tie everything together. So the next time you look at a photograph of distant galaxies curved into rings, know that you are seeing gravity made visible, the invisible hand of the cosmos tracing its design upon the canvas of light. Every curve is a story of mass and time, every distortion a whisper from something unseen. And in that whisper you can almost hear the voice of the universe saying, "Nothing travels alone, not even light." If you listen closely, you might hear it, not with your ears, but with your imagination. A sound older than any planet, older than stars, older than memory itself. The faint hum of the universe still echoing from the moment it began. This is the cosmic symphony, the hidden music of creation. For most of human history, space was thought to be silent. A vast vacuum, empty of air, empty of sound. And in one sense, it is. There are no waves of pressure, no air to carry a vibration from one place to another. But that doesn't mean the universe is quiet. Because while sound cannot travel through space, vibration can. Ripples in space-time itself, called gravitational waves, and fluctuations in cosmic radiation that form the background rhythm of existence. When the universe was born, it rang, not like a bell, but like an ocean struck by light. The Big Bang wasn't an explosion in space, it was the creation of space. A swelling of energy that set every atom, every photon, every possibility into motion. Those motions, those tiny fluctuations, became the foundation of everything that exists today. If we could somehow translate them into sound, the universe's earliest moments would play like a deep, low note, vibrating across all of reality. Scientists have done exactly that. By converting patterns in the cosmic microwave background into frequencies we can hear, they've created audio maps of the infant universe. The tones are slow, rumbling, and haunting. A deep, primordial chant that seems to come from nowhere and everywhere at once. It is the sound of density itself, of matter gathering, collapsing, forming stars. To hear it is to listen to time taking shape. And these cosmic vibrations didn't end after the Big Bang. They continue even now. Every supernova, every collision of black holes, every merging of neutron stars sends out waves, distortions of space-time that ripple outward like the surface of a pond. In 2015, humanity heard these waves for the first time. The LIGO Observatory detected a faint signal lasting less than a second. A chirp, caused by two black holes colliding over 1 billion light-years away. It was the sound of gravity itself, the whisper of an event so powerful that it shook the fabric of the universe. Since then, dozens more have been recorded, each one unique, some deep and slow, others sharp and brief, each a celestial heartbeat marking the dance of creation and destruction. We can't hear them without special instruments, but if we could, the universe would never be silent. It would sing with the music of space-time, a chorus too vast, too ancient, and too patient for human ears. And yet, in our own small way, we are part of that music. The atoms in our bodies vibrate with energy born in those first cosmic waves. The iron in our blood, the calcium in our bones, once resonated with the pulse of dying stars. Even the electricity of our thoughts is part of that rhythm. Tiny oscillations echoing the same harmony that governs galaxies. We are not merely observers of the cosmic song. We are instruments within it. Sometimes when you stand beneath a clear night sky, you might feel something shift inside you. A strange quiet that feels like listening. Perhaps it's because your mind recognizes the rhythm, the faint memory of the first sound the universe ever made. It's not a sound you can capture, but a presence you can feel. A reminder that silence is not absence, but the background of all creation. Astronomers call this hum the relic sound, a fossil of vibration carried across billions of years. They describe its spectrum, its peaks and valleys, its frequencies, but no mathematics can describe what it feels like to imagine it. It's like hearing the echo of a memory you never lived, a lullaby sung by the cosmos to itself. If we could play the universe's history as sound, we would hear it deepen over time. The early notes, sharp and fiery, would mellow into a slow bass as galaxies formed and cooled. Each burst of starlight would be a spark of melody, each supernova a drumbeat of creation. And here now, billions of years later, we exist in the long, sustained chord of its aftermath. A note still fading, still resonating, still alive. The universe has never stopped singing. We just learned how to listen. Through radio telescopes, through gravitational detectors, through our own quiet moments of reflection. And in that listening, we rediscover the truth, that every pulse of energy, every flicker of light, is part of a timeless composition that began before language, before thought. You don't need an instrument to hear it. You only need stillness. Because when you are still enough, you realize the silence around you is not silence at all. It is the sound of everything that ever was, still humming softly beneath the stars. The universe is not silent. It never was. It is a song without end, and every living thing is part of its refrain. When you look at the night sky, it seems scattered and random, stars shining in every direction, galaxies like grains of dust across infinity. But if you could step far enough back, far beyond even the edge of what our telescopes can see, you would realize that the universe is not random at all. It is woven into a pattern, an enormous, invisible structure known as the cosmic web. This web is the largest structure ever discovered. It stretches across more than 100 billion light-years, a vast network of filaments made of dark matter, hydrogen gas, and galaxies. Imagine threads of light and gravity, billions of glowing beads, galaxies, connected by lines too faint to see, each one pulled together by invisible hands. Between those threads lie enormous voids, regions so empty that entire clusters of galaxies could pass through them without ever meeting a single star. In this grand architecture, galaxies are not isolated islands. They are nodes, points of intersection in a sprawling network that binds the universe together. Gravity acts as the weaver, dark matter as the thread, and time itself as the loom. Over billions of years, matter flowed along these invisible lines, collecting in dense knots where galaxies formed, and leaving behind the dark spaces in between. Astronomers have mapped the cosmic web using data from galaxy surveys and computer simulations. The results are breathtaking. A three-dimensional tapestry of filaments, clusters, and voids, shaped by gravity on a scale beyond comprehension. Some filaments stretch for hundreds of millions of light years, connecting galaxies the way rivers connect oceans. Others twist and merge, creating cosmic highways through which matter and light still travel today. If you could drift through this structure, you'd see galaxies glowing like fireflies along invisible bridges of dark matter. You'd pass through shimmering clusters where thousands of suns gather in a single breath, then through vast, silent spaces where almost nothing exists. In the cosmic web, the universe reveals both its density and its emptiness, its fullness and its quiet. And yet, this structure began as something impossibly small. When the universe was young, just a few 100,000 years after the Big Bang, tiny fluctuations in density appeared in the sea of primordial matter. Those fluctuations, measured as faint ripples in the cosmic microwave background, became the seeds of everything that followed. Over billions of years, gravity magnified those ripples, pulling matter together to form filaments, clusters, and galaxies. The web of today. It's humbling to realize that every atom in your body, every element that built your world, once flowed through those same cosmic rivers. The hydrogen in your blood may have drifted for billions of years along a filament of gas before becoming part of a star, before that star created heavier elements, before those elements became you. You are, in every sense, a thread within the web. Scientists call this structure self-similar. No matter where you look or how far you zoom in, the same patterns appear. Clusters, connections, voids. It's as if the universe repeats itself endlessly, from galaxies to atoms to neurons in the human brain. In fact, when researchers compare computer models of the cosmic web to maps of neural connections in the brain, the resemblance is uncanny. The universe and the mind share the same geometry, a network of nodes and pathways carrying energy and information. Perhaps consciousness itself is another kind of cosmic web, woven from the same principles that shape galaxies. If the universe could think, perhaps it would think the way we do, through connections, through relationships, through patterns forming and dissolving in time. And if we could listen to the cosmic web, it would sound like slow breathing, the steady exhalation of gravity balancing expansion. Astronomers can even see the web evolve. Over billions of years, its filaments grow thinner and longer as dark energy drives galaxies farther apart. Someday, in the distant future, the threads may stretch beyond visibility, and the cosmic web may fade into darkness, its structure still there, but unreachable from any single point of light. But for now, it remains. The greatest map ever drawn, the silent skeleton of everything that exists. Every galaxy, every planet, every being lives within this web, connected not just by gravity, but by origin. We are bound by the same forces that sculpted the stars. So when you stare into the night sky, you're not just looking at distant points of light. You're looking at the architecture of existence, a masterpiece made of nothing more than motion and time. And perhaps that's the greatest secret of the cosmic web, that in its delicate design, we find the same truth reflected everywhere, from the smallest cell to the largest galaxy cluster, that everything, everywhere is connected. In the endless dark between the stars, there are worlds without suns, planets cast adrift, untethered, unseen. They wander through space like ghosts, alone in the cold. Their only companions the faint glow of distant galaxies. Astronomers call them rogue planets, and they are among the most haunting objects in the cosmos. Most planets form in the comforting light of a star, their orbits stable, their climates defined by warmth and distance. But some are torn away, flung from their birth systems by gravitational chaos, the violent push and pull of larger worlds. Others may form alone, born from collapsing clouds of gas too small to ignite into stars. They drift endlessly through the interstellar dark, carrying the memory of light long lost. It's believed that there may be more rogue planets than stars in our galaxy. Billions of silent travelers, each following its own invisible path through the void. Most are impossible to see directly, revealed only when they briefly pass in front of distant stars, bending and dimming their light for a fleeting moment. These cosmic shadows pass quickly, like whispers that prove something vast and unseen has moved between us and eternity. What would it be like to stand on one of these orphaned worlds? The sky would be a darkness deeper than anything on Earth. No sunrise, no sunset, only the eternal glow of faraway constellations. Your footsteps would fall in silence. Your breath the only sound in a frozen wasteland, where the air itself may not exist. And yet, not all of these worlds are entirely dead. Some may still retain internal heat, the leftover energy from their birth or from radioactive decay deep within. That heat could sustain subsurface oceans beneath thick shells of ice, just as moons like Europa and Enceladus do in our own solar system. Even drifting through total darkness, such worlds could harbor life, creatures that have never seen the sun, thriving on the warmth of their planet's core. It's a strange and beautiful thought, that life might not need light at all, that somewhere in the dark between the stars, beneath miles of frozen crust, there could be oceans teeming with movement, organisms feeding on chemical energy instead of sunlight. Entire ecosystems could exist in perfect isolation, never knowing the stars that birthed them. Rogue planets remind us that the universe is not built for comfort. It is built for endurance. These worlds survive not because they are bright, but because they adapt. Because even in the coldest reaches of space, there is still motion, still heat, still the quiet persistence of being. Some scientists suggest that Earth, too, could one day become a rogue world. If the sun were to die, expanding into a red giant and then collapsing into a white dwarf, our planet might be pushed outward or cast adrift entirely. It would drift through the galaxy, frozen and dark, its oceans turned to ice, its mountains locked in eternal night. But deep beneath the crust, heat from radioactive decay might linger for millions of years. Perhaps in that far future, some remnant of life, microbial, patient, persistent, would remain. In that way, even Earth might join the silent migration of the lost worlds. To study rogue planets is to study isolation itself. They are the pure expression of solitude, planets with no orbit to return to, no dawn to mark time, no star to give them identity. And yet, in their loneliness, there is a kind of peace. They do not burn, they do not collapse, they simply drift. Proof that even in the emptiest places, existence continues. If you could watch one pass through space, you'd see only darkness at first. Then perhaps a faint glimmer, infrared light leaking from deep within, the last warmth of its creation. You'd realize that what looks like emptiness is in fact filled with worlds, invisible, ancient, and free. Freedom, after all, has a cost. To be unbound is also to be alone, and that is the paradox of the cosmos, that it creates wanderers in order to fill its silence. Rogue planets drift endlessly, but they are never meaningless. Each one carries history, the dust of stars, the memory of gravity, the chemistry of life's beginnings. Somewhere a rogue planet may pass near another system, its gravity tugging briefly at distant stars, its frozen heart warmed for a moment by starlight before continuing on its journey. It will leave no trace, no mark on the galaxies it crosses, but its presence will ripple through space, a reminder that motion is the universe's only constant. So when you look into the night and see only stars, remember that between those points of light lies a second universe, one made of darkness, of wandering worlds, of planets that travel alone yet remain part of the same grand story. They are the echoes of creation, the drifters of eternity, moving without destination through the sea of stars, forever searching, forever free. Every atom in your body, every carbon in your cells, every oxygen you breathe, was once part of a star. Before there were planets, before there were oceans, before there was life, the universe was a cloud of hydrogen and helium drifting in darkness. And it was only when the first stars were born, when gravity pulled that gas together and ignited the first fires of fusion, that the ingredients for everything we know began to exist. Stars are the furnaces of creation. Deep within their cores, hydrogen atoms fuse into helium, releasing energy that shines across billions of light years. But that's only the beginning. In the most massive stars, fusion continues. Helium becomes carbon, carbon becomes oxygen, and so on through heavier and heavier elements, until the star's core can no longer sustain the weight of its own gravity. Then, the balance breaks. The star collapses inward, and in one brief, blinding instant, it explodes as a supernova. A single event so powerful it can outshine an entire galaxy. For a few days, its brilliance rivals all the stars around it combined. But the true miracle lies not in the light, but in what that light carries: the birth of new elements. In that violent moment, the universe forges gold, silver, iron, calcium, the materials that will one day form planets, oceans, mountains, and living things. Every element heavier than iron was created in these stellar deaths, scattered into space as stardust. Over millions of years, that dust gathers into clouds, forming new stars, new worlds, new beginnings. Each generation of stars enriches the next, building complexity upon simplicity, life upon light. Carl Sagan once said, "We are made of star stuff." It's not a metaphor, it's physics. The atoms that make your heart beat were once inside a supernova. The calcium in your bones once burned in the core of a dying star. And when you exhale, some of that carbon may someday drift through space again, to be reborn in another system, another sky. It's a strange kind of immortality, one not of memory, but of matter. Stars live, die, and pass themselves forward. You, me, every creature, every mountain and sea. We are fragments of their endless cycle. When you think about it, the stars are not above us. They are within us, woven into every breath, every heartbeat, every thought that wonders where we came from. But even the death of stars can take many forms. Some collapse gently into white dwarfs, cooling slowly over trillions of years. Others collapse more violently, becoming neutron stars, dense remnants no larger than a city, spinning hundreds of times per second, their magnetic field strong enough to warp space around them. And some, the most massive of all, collapse entirely, forming black holes, the final expressions of gravity and silence. Yet, none of these deaths are truly endings. They are transformations. The materials they release, dust, radiation, magnetic fields, become the seeds for future stars. In the heart of a nebula, this cycle begins anew. Gas clouds swirl and collapse under gravity's hand, igniting once again the fires of fusion. A new star is born, surrounded by a disk of dust and debris, from which planets, moons, and comets will eventually form. This is how solar systems come to be. And somewhere, within one of those systems, life takes shape. A spark within stardust, a consciousness born from chemistry. When you trace your lineage far enough back, it doesn't end at the first humans, or the first animals, or even the first cells. It ends with the stars. So the next time you look at the night sky, try to remember that what you're seeing is not something separate from you. You're not looking at the stars. You're looking into yourself, the older version of you, the version that existed billions of years before your birth. When the universe was still learning how to shine, and one day, far into the future, our sun will join that cycle. It will swell into a red giant, its light consuming Mercury, Venus, and perhaps even Earth. Then, it will shed its outer layers, leaving behind a white dwarf, a glowing ember surrounded by a nebula of color. From that debris, new stars will form, new worlds will rise, and the atoms that once built our oceans and mines will travel onward into the next generation of the cosmos. In the grand rhythm of existence, nothing is ever truly lost. Energy changes, matter transforms, but the story continues. You are not just alive in this moment. You are part of an unbroken chain that began in the first light of the universe. And when you breathe out, some of those ancient atoms return to the sky, ready to become part of something new once again. Because in the end, the stars do not die. They only change shape, just as we do. They burn, collapse, and scatter, but their essence remains. And from their ashes, the universe remembers how to begin again. Far beyond the glow of our own galaxy lies a secret ocean, not of water, but of light stretched thin by time. Everywhere we look, even in the darkest corners of the universe, there is a faint shimmer, a quiet glow that fills all of space. This light is ancient, older than galaxies, older than stars. It is the afterglow of the beginning itself, the cosmic microwave background, the echo of the Big Bang still whispering through the void. Over 13 billion years ago, the universe was not a starry sky, but a hot, dense fog, a storm of particles and radiation so intense that light couldn't travel freely. Photons collided constantly with electrons and protons, bouncing around like echoes in a sealed chamber. Space was bright, but it was also opaque, a glowing mist of pure energy. Then, about 380,000 years after the Big Bang, everything changed. The universe cooled enough for electrons to combine with protons, forming the first neutral atoms. For the first time, light could move unhindered. Those first free photons began their endless journey outward, and we still see them today, stretched by the expansion of space into soft microwaves, a faint glow bathing the entire cosmos. If you tune a radio between stations, a small fraction of the static you hear, about 1%, is that ancient light. It's the leftover radiation from creation itself, still humming softly, still telling the story of the universe's birth. Discovered by accident in 1965 by Arno Penzias and Robert Wilson, the cosmic microwave background, or CMB, became the most compelling proof that the Big Bang truly happened. What they heard wasn't noise. It was the universe itself, still resonating from the first explosion of time and space. Since then, satellites like COBE, WMAP, and Planck have mapped this glow in extraordinary detail. What they found wasn't uniform. The CMB contains tiny fluctuations, microscopic temperature differences no greater than 1 part in 100,000. Those ripples are the fingerprints of the early universe, the first signs of structure, the seeds that would one day grow into galaxies, stars, and planets. Imagine the entire universe as a sea frozen mid-wave. Those ripples are what gave rise to everything. Without them, matter would have been evenly spread, and nothing, not even you, would exist. The CMB is more than a relic. It's a map of potential, a snapshot of what the cosmos looked like when it was only a child. Through its subtle variations, scientists can measure almost everything: the universe's age, its shape, its composition. From that light, we learned that the cosmos is about 13.8 billion years old, that it is mostly made of dark matter and dark energy, and that it is remarkably flat. Its geometry stretched by the mysterious inflation that happened in its earliest moments. But perhaps the most astonishing thing about the CMB is not its data, but its meaning. It tells us that the universe has memory, that even after billions of years, it still carries the sound of its first breath. That faint glow connects us to a time when everything that exists was contained in a single, trembling point of energy. If you could see it with your eyes, the CMB would not look like light, but like a veil of fire stretched across the entire sky. A background of warmth so gentle it sits just 2.7 degrees above absolute zero, barely warmer than nothing. And yet, in that almost nothing lies the blueprint of everything. Every galaxy, every star, every atom of you. Some scientists have even converted the fluctuations in the CMB into sound. When translated into audible tones, the early universe hums in deep, resonant frequencies, slow waves like the heartbeat of creation. Each tone represents regions where matter was slightly denser, each beat a prelude to stars yet unborn. Listening to it is like hearing the music of time itself. That hum, constant, omnipresent, eternal, is the universe's oldest whisper. It's the closest we will ever come to hearing the moment existence began. And while its echo grows fainter with each passing age, it will never vanish completely. Even as galaxies drift apart, even as stars fade and black holes swallow light, that radiation will still cross the darkness, still carrying the memory of the beginning. One day, far into the future, civilizations billions of years from now may no longer see the CMB. By then, the universe's expansion will have stretched it beyond detectability. The record of its origin will fade from view. But for now, for us, it's still there, written across the entire sky like an invisible scripture. Everywhere you look, that light surrounds you. You're swimming in it, bathed in the oldest light in existence. So when you step outside and feel the stillness of the night, remember, the silence above you isn't truly empty. It's filled with the echo of creation. A glow so ancient it has forgotten the moment it began, yet still continues to sing through the fabric of space. It's the universe's way of remembering itself, and in its faint, eternal hum, you can hear the truth that everything that has ever existed still lives, still resonates, still shines. There is a law that nothing can move faster than light. It defines the limits of motion, the boundaries of causality, and the rhythm by which the universe unfolds. But what if space itself doesn't obey that rule? What if the stage on which everything moves, the very fabric of space-time, can stretch, bend, and expand without limit? In the first instant after the Big Bang, that is exactly what happened. The universe underwent a phase known as cosmic inflation, a brief, breathtaking expansion when space itself grew faster than the speed of light. In less than a fraction of a second, the cosmos ballooned from smaller than an atom to larger than the observable universe. Galaxies, stars, and planets did not yet exist. Only pure energy, spreading outward at impossible speed. This didn't violate Einstein's theory, because the law of relativity forbids matter or information from moving through space faster than light. But space itself has no such restriction. Space can expand. And in doing so, it can carry everything within it farther apart without breaking a single physical law. It's a subtle but profound distinction, one that defines the universe's past and its future alike. Even today, that expansion continues. Galaxies drift apart, their light stretched into longer, redder wavelengths. This stretching of light is what we call cosmological redshift, a fingerprint of the universe's constant motion. The farther a galaxy is, the faster it recedes. Some are now moving away so quickly that their light will never reach us. They have crossed a cosmic horizon beyond which communication, even by light, is impossible. It's humbling to realize that there are parts of the universe we can never see, no matter how powerful our telescopes become. Their light left billions of years ago. And yet, because space between us continues to grow, that light will never arrive. In a very real sense, those regions are not merely distant. They are beyond existence as we can ever know it. Astronomers call this the observable universe. the portion of the cosmos from which light has had time to reach us since the beginning of time itself. It's a sphere roughly 93 billion light-years across, and everything we've ever seen or measured lies within it. But beyond that boundary, space continues, perhaps infinitely, perhaps looping back on itself like a cosmic ocean without shores. Some theories suggest that the universe might be infinite in size, that the galaxies we see are only one small region of an endless expanse that never repeats exactly, yet contains every possible arrangement of matter. If that's true, there could be other regions where stars, planets, and perhaps even beings like us exist, not as copies, but as parallel outcomes of infinite possibilities. A reality so vast that our entire cosmic history would be just one note in an endless symphony of creation. But even within our observable realm, the expansion is not slowing, it's speeding up. Astronomers discovered this in the late 1990s when studying the light from distant type Ia supernovae. Instead of slowing down under gravity's pull, those distant galaxies were accelerating away. The cause remains one of the deepest mysteries in science, a phenomenon we call dark energy. Dark energy isn't a force pushing galaxies outward. It's a property of space itself, an intrinsic energy that increases as space expands. The more the universe grows, the more dark energy there is, driving faster and faster expansion. It currently makes up about 70% of the entire cosmos, yet we don't know what it truly is. Is it the energy of the vacuum itself? A new field of physics we haven't discovered? Or something even stranger? The echo of another universe pressing against our own. If dark energy continues to dominate, the universe will expand forever. Galaxies will drift apart until even their light fades. Stars will burn out, and the cosmos will grow cold and dark. Eventually, only black holes will remain, and even they will evaporate through Hawking radiation, leaving behind a sea of invisible particles. It's called the heat death of the universe, not an explosion, but an endless sigh as everything fades into equilibrium. Yet, some scientists imagine other endings. If dark energy changes over time, the expansion might reverse, causing the universe to collapse inward in a big crunch, a rebirth through destruction. Others propose a big rip, where expansion becomes so extreme that galaxies, stars, and even atoms are torn apart. No one knows for certain. The only thing clear is that the universe is not static. It breathes, stretching, evolving, transforming on scales too vast for human time to comprehend. And maybe that's the beauty of it. We live within a moment, a fleeting pause in the universe's expansion, long enough for life to form, for stars to burn, for consciousness to wonder. We are the awareness of the cosmos, the part of it that looks back and asks why. And as we watch galaxies drift into the distance, we are also watching time itself unfold. A motion so slow, so graceful that it feels like eternity. The universe doesn't rush. It expands with purpose, carrying its story forward one light year at a time. And though we may never reach its edge, we are part of its motion, woven into its rhythm. We are the observers of an infinite horizon, watching light fade, and in that fading discovering the profound truth that everything moves, and nothing ever truly stops. Somewhere in the quiet reaches of the Milky Way, a cluster of stars burns in near-perfect synchrony. They orbit, collide, merge, and dissolve, each motion governed by the same invisible laws that shape everything else in the universe. But among them, there are outliers, stars that vanish without warning, or flicker in patterns no one can predict. These mysteries remind us that even in the most precise clockwork of the cosmos, there is room for chaos and beauty born from the unknown. Astronomers have observed stars that seem to disappear from one century to the next. Old photographic plates from observatories show bright points of light that no longer exist today. Some of these stars may have gone supernova, collapsing into black holes or neutron stars, their brilliance fading into silence before we ever saw the explosion. Others may simply have dimmed beyond visibility, their energy waning as their fuel ran out. But a few cases remain unexplainable. Stars that didn't explode, didn't fade, but simply blinked out of existence. It's as if the universe occasionally takes a deep breath, and in that moment, something disappears between one heartbeat and the next. Some theorists suggest these vanishings might be linked to rare cosmic events, massive collapses, gravitational lensing, or even transitions between dimensions. It sounds like science fiction, but so did black holes once, and now we've photographed one. The universe hides its truths in riddles that only time can decode. Even stars that survive their lifetimes don't truly endure. When a massive star collapses, it creates a neutron star or black hole, objects that push the laws of physics to their edge. A neutron star can pack the mass of our sun into a sphere no larger than a city. A teaspoon of its matter would weigh billions of tons. Its gravity bends light, its magnetic fields can tear atoms apart, and its surface burns with radiation so intense it could vaporize anything that came near. Some neutron stars, called pulsars, rotate hundreds of times per second, beaming out pulses of energy like a cosmic lighthouse. Their precision is so perfect that astronomers use them as natural clocks, measuring the passage of time across the galaxy. Others, even more extreme, become magnetars. Neutron stars with magnetic fields trillions of times stronger than Earth's. If a magnetar were as close as the moon, its magnetism could erase every digital record on our planet. It's difficult to imagine such power contained in something so small, a mountain-sized star that hums with the violence of creation itself. And then there are the quiet giants, white dwarfs. These are the remnants of stars like our sun, cores of carbon and oxygen left behind after their outer layers drift away. White dwarfs no longer burn with fusion. They glow with residual heat, fading slowly over billions, even trillions of years, until they become black dwarfs, cold, invisible relics of once bright suns. None exist yet. The universe isn't old enough for that. But one day, when every star has burned out, they will fill the dark like embers of an extinguished fire. Every stage of a star's life tells a story of struggle against gravity. From birth in a nebula to death as a black hole, each phase is a balance between outward energy and inward collapse. When energy wins, the star shines. When gravity wins, it falls. And through that balance, the universe learns how to evolve. Even now, new stars are forming. In the Orion Nebula, in the Carina Cloud, in countless nurseries of dust and gas, each one igniting quietly in the darkness, each one destined to live, to shine and to die. Our own sun was born from such a place, and someday it will end the same way. Not with an explosion, but with a gentle shedding of its outer layers, leaving behind a faint, glowing shell, a planetary nebula drifting through the void. From afar, those nebulae are some of the most beautiful sights in the cosmos. Vast clouds shaped like butterflies, rings, or ghostly eyes. They are the final exhalations of dying stars, their gases illuminated by the heat of what remains within. Every color tells a story: red for hydrogen, green for oxygen, blue for helium. It's as if the star in its last moments paints its own portrait upon the sky. And yet, even that light will fade. Over unimaginable timescales, the universe trends towards simplicity. Stars burn out, galaxies drift apart, and energy becomes too diffuse to form new worlds. It's called the entropy of the cosmos, the slow unfolding of order into quiet equilibrium. But it's not an end, it's a transformation, because even in the future darkness, particles will still move, space will still stretch, and the memory of light will still hum beneath the silence. The universe doesn't end. It simply changes form, becoming what it always was: energy in motion, time unfolding, possibility without limit. Perhaps that is the lesson of the stars, that endings are never final, that every collapse carries the seed of new creation. Somewhere, out there in the dark, a new nebula is forming even now, its dust gathering, its light preparing to burn, and when it does, it will shine with the atoms of countless dead suns, the ashes of stars reborn as flame. In this we find the quiet truth of existence, that destruction and creation are not opposites, but partners in an eternal dance. The stars teach us that to fall is not to vanish. It is simply to begin again. Somewhere deep in time, long after the last star has burned out, the universe will grow quiet. Galaxies will have drifted so far apart that their light no longer reaches one another. The night sky, once a tapestry of brilliance, will fade into a black, eternal calm. And yet, even in that distant future, the universe will still be changing, because silence does not mean stillness, and darkness does not mean the end. Physicists call this distant era the degenerate age, a time when matter itself begins to unravel. Stars will have long since died, leaving behind white dwarfs, neutron stars, and black holes. Even those remnants, over trillions of years, will fade away. White dwarfs will cool into invisible black dwarfs, their once blazing surfaces sinking to near absolute zero. Neutron stars will slow their spin, their magnetic fields collapsing into quiet stillness. Only black holes will remain, islands of gravity adrift in an ever-expanding ocean of nothing. But even black holes are not eternal. According to Stephen Hawking's prediction, they emit faint radiation as quantum fluctuations dance across their event horizons. This radiation, now called Hawking radiation, slowly drains a black hole's mass over unimaginable spans of time. The larger the black hole, the longer it lives. A supermassive black hole might endure for 1064 years, a number so vast it defies imagination. Yet, even that colossus will one day vanish in a final burst of light, its gravity undone, its energy returned to the void. When the last black hole evaporates, the universe will enter its final chapter, the dark era. No stars, no light, no warmth, just a sea of subatomic particles, photons, neutrinos, and electrons, drifting endlessly through space too vast to ever meet. Temperature will approach absolute zero. Time itself will lose meaning. And still, quantum fluctuations, those restless ripples in reality, will shimmer faintly in the background, a soft static that refuses to disappear. It sounds like an ending, but perhaps it isn't, because even in the deepest quiet, the universe remembers how to begin again. Some cosmologists believe that the death of one universe could give rise to another, that from the ashes of entropy, a new Big Bang might ignite, a new space-time, a new flow of energy, a new chance for light. Others propose that the universe may already be cyclic, that every expansion is followed by collapse, every death followed by rebirth. In this view, we are living in one breath of a cosmic rhythm that has played for eternity, each universe leaving faint echoes in the next. Perhaps those echoes are hidden in the cosmic microwave background, tiny imprints of worlds long gone. If that's true, then creation itself is infinite. There is no first moment and no last, only transformation, a song with no beginning and no end. Even if the universe does fade to black, the atoms that once built galaxies and life will not be wasted. Energy cannot be destroyed. It only changes form. The particles released in that final darkness will drift forever, carrying with them the imprint of everything that ever was. Every star, every breath, every dream. They will not remember their shapes, but they will still hold the essence of existence. In them lies the raw potential for what might come next. And maybe, just maybe, our story will not vanish completely. Maybe in some far-flung future, a fluctuation in the void will grow, energy will condense, and the cycle will begin anew. Somewhere in that new universe, the laws of physics will take shape again. Hydrogen will form, stars will ignite, and light will return to fill the dark. And among those stars, life will one day open its eyes. Look up at the night sky and wonder, just as we do now, where it came from. It's possible that none of us will ever know how the story truly ends. We exist in a fleeting moment between birth and silence, in a universe still young enough to sparkle. But that moment, this single cosmic heartbeat, is enough, because it contains everything: the memory of the beginning, the awareness of the present, and the imagination of all that could still be. The cosmos doesn't rush to its destination. It drifts gracefully toward transformation. It knows that endings are not failures. They are transitions. When a star dies, it creates the elements for new worlds. When galaxies collide, they trigger the birth of new suns. When universes fade, they make room for others to bloom. So perhaps the final lesson of time is this: that nothing is truly lost. Not light, not matter, not even us. We are fragments of a story that continues beyond understanding. The universe dreaming of itself, over and over, forever. At the edge of all things, beyond time, beyond distance, beyond light, there is a kind of silence that feels alive. It's not the silence of absence, but the stillness of everything that has ever been, folded into one infinite moment. Perhaps this is where the universe breathes. Perhaps this is where it remembers itself. We began our journey with light, the first spark that broke through the darkness after the Big Bang. And now, after crossing galaxies, stars, and time itself, we return to that same silence from which it came. The universe, vast as it is, has always been a story of transformation. Energy becoming matter, matter becoming life, life becoming awareness, and awareness returning to wonder. When we gaze into the night sky, we are not looking into space. We are looking into time. Every star we see is a message from the past, a light that has traveled for millions or even billions of years to meet our eyes. Some of those stars no longer exist, their light a ghost of what once was. And yet, here it is, still shining, still reaching us across eternity. The universe speaks in this language of delay, a reminder that nothing truly ends, only changes form and continues onward. Even now, the photons that left our sun 8 minutes ago are crossing space to touch the surface of Earth. Others, emitted from galaxies at the dawn of time, are still on their way, their journey unending, their message simple: light endures. In that sense, you too are part of this cosmic persistence. You are built from atoms that once burned in the hearts of stars, from carbon born in supernovae, from hydrogen forged in the first seconds of existence. Every breath you take carries particles that have passed through countless worlds before finding you. You are the continuation of the universe's memory, its consciousness shaped into thought. The cosmos has always been reaching toward complexity. From simplicity came motion. From motion came structure. From structure came awareness. And now, through that awareness, the universe can finally see itself. You are not separate from the galaxies or the stars. You are their witness, their echo, their reflection. Perhaps that is why silence feels sacred, because when you stop and listen, you can feel that vast connection within you. The rhythm of your heartbeat mirrors the pulse of cosmic expansion. The electrons in your body vibrate in the same frequencies as those that hum in the distant microwave background. You are the small expression of something impossibly large, a temporary arrangement of matter that allows the universe to observe its own beauty. And even though the night may appear still, everything is in motion. Planets orbit, stars drift, galaxies collide, and the very fabric of space continues to stretch. What feels eternal to us is merely a moment in cosmic time. Yet, that moment is enough, because within it, the universe finds meaning through your awareness. Look again at the stars. Every one of them is a story unfolding, a sun rising on unseen worlds, a possibility that life might be watching us in return. Perhaps somewhere, a being under another sky is also wondering about the same thing, feeling the same awe, the same quiet belonging. If consciousness exists here, then perhaps it exists everywhere. Because the universe does not create in isolation. It creates in rhythm, repeating patterns of light and thought across endless distances. And so, as we drift back through this cosmic journey, past the rogue planets and star nurseries, past black holes, supernovae, and ancient light, we return to where we began, a single spark in an infinite dark. That spark is not just the beginning of everything. It is the promise that everything continues. Every end is a return. Every silence is a seed. Every darkness holds light yet to be born. The universe is not a cold machine. It is a living process, a grand act of becoming. And you, standing beneath its endless sky, are proof that it can look upon itself and feel wonder. You are the question and the answer. You are stardust that learned to dream. So tonight, let the cosmos cradle your thoughts in its quiet arms. Let the rhythm of existence guide your breath. Remember that nothing is truly separate, not the stars, not the dust, not you. Everything you are, everything you've ever been, is connected to everything that ever was. And when you close your eyes, you will feel it, the slow pulse of eternity, beating softly beneath all things. You are part of that pulse. You are part of that silence. You are part of that infinite, unfolding story. The story the universe has been telling since the first light was born. Sleep, knowing that the cosmos continues to sing, and that somewhere, in the deep quiet between the stars, it is whispering your name. Good night, and see you in the next video.